Hello everyone, let's solve question 29 of GATE paper CS1 2025. Suppose in a multi-programming environment, the following C program segment is executed. The process goes into input-output queue whenever an input-output related operation is performed. Assuming that there is always a context switch whenever a process requests for an IO, and also whenever the process returns from an IO. The number of times the process will enter the ready queue during its lifetime, not counting the time the process enters the ready queue when it initially is. Answer in integer. Now, this is where I have to write the integer value as an answer. It is not an MCQ question anymore. So let's understand the prerequisite of this particular problem and try to solve it. So this is a classical operating system question where we need understanding of process states, which is ready, running, waiting, input, output, context switching, how input output affects scheduling, and how many times a process re-enters the ready queue due to input and output. Let's understand the process lifecycle basics. So, a process in a multi-programming environment can be have three major states. Ready, that means it is waiting for CPU. Running, that means it is currently using the CPU. And waiting, which is blocked, waiting for input slash output complete. Transition, ready to running when CPU is allocated. Running to waiting when input and output is requested through scanf and printf. Input for scanf, output to printf. Waiting to ready after input and output completion. Basically, the input output interrupt. The important role in the question is there will be always a context switch whenever a process requests for an input output, and also when a process returns from the input output. ये जो लिखा है ना, this line is written. This is a very big context written. This is very important, and everyone should focus on this. Okay. This implies that process leaves the CPU and enters the input output queue, that means the context switch. And once the input and output completes, it enters back to ready queue, which is another context switch. Each input output causes the process to re-enter the ready queue once the input output completes. Let's analyze the code. So there are what kind of input outputs here? Let's try to analyze that. So the very first is this one. And uh, here we are actually doing the output. This is input operation. And this is the output operation where we are, this is one time and this is for 20 times because the loop will run for I is equal to 0 and I till I is equal to 19. So from 0 it starts. From 0 it starts and at 20 is not included. It stops at 19. So the loop is running a total of 20 times. And there is one scanf, so total 21 times the input output has been handled. Okay, so as you can see that for the first input output and printf input output is repeated 20 times. So scanf goes into waiting and then back ready. Printf inside loop repeated 20 times, so 20 outputs. So total input output operation is one scanf plus 20 printf is equal to 21. When does the process enters the ready? We don't count the first time it enters the ready queue at the start. But for each input and output, the process requests an input and output, it goes into the waiting or the block list. Once the input output is done, OS place it in the ready queue. तो भाई कुछ इस तरीके से है जब जो भी प्रोसेस चल रहा है जब वो इनपुट आउटपुट के लिए जाएगा तो इट डिपेंड्स ऑन द यूजर ना व्हेन द यूजर एंटर्स इट सो टिल देन इट इज वेटिंग दैट मींस ब्लॉक once the input has been provided then the operating system plays that particular into ready queue. So for each input and output, the process will leave the CPU, which is context switch, and re-enter the ready queue once the input and output is done. So there are 21 input output operation. The process will re-enter the ready queue total of 21 times. What is the process? First, process request input output goes into the waiting or the block. Once it is done, it enters or OS places back into the ready queue. So the final answer to this particular question is 21. That's it for this particular video. Take care. Bye bye. See you guys in the next video.